In continuation of Euler's theorem, the third sum we are going to discuss very quickly. Here in third sum, the value of u is given. U is equal to cos of xy. If u equals cos of xy by x square plus y square, u is equal to cos of xy by x square plus y square plus under root x square plus y square plus xy square by x plus y. Then find the value of x del u by del x plus y del u by del y at the point 1, 1. Okay. See, in last sum, there were two different terms, and in this problem, there are three different terms. This is the first term. The terms are separated by plus minus equal to sign. Second term and third term. In last problem, we have denoted first term by u, first term by v, second term by w, and we applied Euler's theorem on it. Now we have here three terms. Okay, so what I am going to do, I am letting v is equal to cos xy by x square plus y square, first term. W equals second term and t equals third. Is it? If this is u, this is v, this is w, and this is t. Therefore, the u becomes v plus w plus t. Is it? Here I am going to find value of n. Here also I will be finding value of n, and for t also I will be finding value of n. Instead of n, you can write here n1, n2, n3 also. It is your choice. Now, as what did I tell you in the last sum? If power of x, here I am writing, here 1 is there in the multiplication, x to the power 0. Here, this function v is in the standard form. See, what is standard homogeneous function? Z is x to the power n function of y by x. Standard homogeneous function of degree n. Now, this function is a function of y by x. So, how do you come to know the degree of each and every term here is same? Degree of this is 2, degree of this is 2, degree of this is 2, like that. This is a function of y by x and multiplied by x to the power n, means here n is 0. Now, here the degree of this term I want, the degree of x square plus y square is what? 2. Degree of this is 2, degree of this is 2, therefore degree of numerator is 2. Here denominator is 1 and degree of 1 is 0. This is the degree of numerator, but this component, numerator component, is coming under the root, therefore it is multiplied by 1 by 2, and the degree is what? 1. 2 gets cancelled and n is 1 for w. Now, what is value of n for t? The degree of numerator is what? 3. See, here is a single term. And when we have the product of two variables, x and y, so we have to add the degrees. Is 1 plus 2 is 3. Degree of numerator is 3 minus degree of denominator is 1. Degree of this is 1. Degree of this is 1. Therefore, degree of denominator is 1. Now, here for v n is 0, for w n is 1, and for t n is 2. Okay. Now I am writing Euler's theorem for v, w and t. by Euler's theorem. But what is required here? In last sum, the second order differential coefficient was required. Now here the first order differential coefficient is required by Euler's theorem for V now. X del V by del X plus Y del V by del Y is equal to N. N is 0. 0 into V. And 0 multiplied by V is what? 0. Okay, this is our equation 1. Right? Now similarly for W, X del W by del X by Euler's theorem, Y del W by del Y is equal to N. N for W is 1. 1 multiplied by W is W. This is our equation 2. Is it? Now for T I am writing Euler's theorem, X del T by del X plus Y del T by del Y is equal to 2 multiplied by N multiplied by T is 2T. Okay, this is our equation 3. Now for V, for W, for T, I have written Euler's theorem, but we want this one. And U is made up of V, W and T. Here I have written U is V plus W plus T. So I am adding these three equations. The equation 1 plus 2 plus 3 gives us, writing directly, okay, X del X. First I am adding first V plus W plus T. V plus W plus T plus second term. Now I am going to add Y del Y of V plus W plus T, V plus W plus T, and similarly I have to add right hand side also, 0 plus W plus 2T, 0 plus W plus 2T. Is it? Now W plus 2T is there. Okay. Now X, therefore X del X of V plus W plus T is what? U. Y del Y of, again, V plus W plus T is what? U is equal to right hand side. W, what is value of W? W is under root X square plus Y square and 2 times T, 2 multiplied by T. T is what? XY square by X plus Y. In this way, we have found value of X del U by del X plus Y del U by del Y. Yes. Now X del U by del X plus Y del U by del Y equals W plus 2 times T. In this way, we found value of this differential component, X del U by del X plus Y del U by del Y. But it remains to find out value of this differential component at 1, 1. Means at the point 1, 1, put X equal to 1, because we want value of this. We want value of this component at X equal to 1 and Y equal to 1. At X equal to 1 and Y equal to 1. Is it? So this is what 1 plus 1 is 2 under root 2 plus here 2 by 2. This is 1, numerator is 1. 2 by 2 is 1. So root 2 plus 1 is the value of X del U by del X plus Y del U by del Y. Is it? Here U is given and x del u by del x plus y del u by del y you have to calculate. Value of this you have to find. But importantly, here u is a function of three terms. There are three terms: first term, second term, third term. So I am denoting this by first term by u v, second term by w, and third term by t. And independently, I am applying Euler's theorem. Prior to that, I found value of n also. Then we have added these three equations so as to get the differential coefficient for w, differential coefficient for u. Okay, and finally, the value of this differential component at the point 1, 1 we have calculated by putting x equal to 1, and y equal to 1. Now the fourth sum we are going to discuss. Okay, I'll increase the speed of writing now. The fourth sum we are going to discuss. If u is equal to, if f is equal to, okay, instead of u, f is there, 1 by x square plus 1 by xy plus log of x minus log y. This divided by x square plus y square. Okay, this function is given to you. Now, previously in previous problem there was u here. The function is denoted by, total function is denoted by f. Okay, then prove that. X del f by del x plus y del f by del y plus 2f is equal to 0. This we have to prove. This is 0. Okay. Now when you solve any problem, so what we have to calculate, what we have to find? Okay, that should be focused, you know. Here f is given and this component is, we have to find value of this component. Value of this component should be minus 2f. So this component is present, x del f by del x plus y del f by del y. Therefore use Euler's theorem. Now we are going to solve it. Okay, as I told you in the last lecture, in the last problem, how many terms are there? This is the first term. Terms are separated by plus minus sign. Okay, and this is third term. Okay, now in these three terms, see, you can denote it by u, you can denote it by v, and you can denote it by w. Okay, u v w, and try to solve this problem. And try to get this value. So you can start like that. U, V, W. Apply Euler's theorem on U. Apply Euler's theorem on V. Apply Euler's theorem on W. Okay. But if you look at this function, very carefully, so what is degree of denominator? What is degree of first term? It is minus 2. Degree of this term is what? Minus 2. And degree of this term is what? Here I am writing log a minus log b is log of a by b. Log of a by b. Okay. Once again I am going to repeat. You can move like that. Let us denote it by u, v, w. Apply Euler's theorem independently. Add all these three equations and get the value. But in this problem particularly, in this function particularly, the degree of each and every term is same. See, degree of this term is minus 2, degree of this term is minus 2, and degree of this term is also minus 2. Okay. Now, so therefore, degree of this term is minus 2, n is common for all. That's why you can solve this problem in a single step, you know. You can solve this problem in a single step. Okay. The degree of, see, function, homogeneous function I am writing in this way. Z is a function of x and y. Okay. Or Z is a function of x and y like this. This is homogeneous function of x and y with degree n. This is also homogeneous function of x and y with degree n. But here only x is replaced by y and y is replaced by x. Okay. As a homogeneous function. As a homogeneous function, meaning of these two is same. Here in this problem, the degree is same. See, degree of numerator is 0, degree of denominator is 2. The degree of numerator minus degree of denominator means minus 2. Degree of numerator is 0 because 1 is there, free constant, and degree of free constant is 0. Minus degree of denominator is 2. See, 1 plus 1 is 2. And here, this is the function of x by y. The degree of denominator, degree of this will be what? X to the power 0 is 0. Degree of numerator is 0. 0 minus degree of denominator is 2. Therefore, degree of each and every term is minus 2. Here, degree, I am writing in short, degree of f given function is minus 2. Degree of given function is minus 2. Therefore, x, or you can write this f of x degree is minus 2, and this is homogeneous function in x1. Okay, 1 by x square, 1 by xy, and x to the power 0 log x by y. You can mention like this, or not necessary to mention. It is not necessary, but I am going to mention it. Our homogeneous function of the type x to the power of the type x to the power n, a function of y by x, y to the power n, function of x by y. Okay, now it has become clear. Now degree of each and every term is minus 2. Therefore, I am solving problem direct using function f. Now by Euler's theorem, what is Euler's theorem? X del f y del x plus y del f y del y. Euler's theorem is what? For z, x del z by del x plus y del z by del y is equal to nz and f. Here instead of z, f is there. Now what is n? N is minus 2. Okay. Now shift minus to f on the left hand side. Is it? This 2f I am shifting here. In this way, we have proved this one. Okay, in 2 to 3 steps we solve this problem. Once again I am going to repeat. You may solve this problem by treating this as u, this as v, this as w. Operate or use Euler's theorem for u, for v, for w. 3 equations you will be getting. Add all of them, so you will be getting this thing. Try to solve for one more step and you will be getting this thing. But what did I do here directly? Because the degree of each and every term is same. Degree of each and every homogeneous function is same. This function is of this type or this type. Okay, it is a material. And when the degree of complete f is minus 2, the directly Euler's theorem on f I have applied and I have solved in 2 to 3 steps. Okay. Now The next sum we are going to solve. If u is equal to x to the power 8 f of y by x. Okay, it is like this, x to the power n f of y by x, and 1 by y to the power 8 f of x by y. This function is this type, y to the power n f of x by y. Then prove that, then find the value of x del u by del x plus y del u by del y. This value we have to find. And secondly, x square del 2u by del x square plus 2xy del 2u by del x del y plus y square del 2u by del y square. Is it? These values of these two components we have to find, and these are the components of Euler's theorem. Okay. Now, here in this problem, in examinations also, this 8 may be replaced by 3, 8 may be replaced by 2, 8 may be replaced by any integer. Okay, 8 may be replaced by n also in general. Now we are going to solve this sum. Here how many terms are there? 2. First term and second term. Okay, here what is the difference between first sum and the second? Okay, see, in this sum, in this sum, the degree of this term is -2, degree of this term is -2, and degree of this term is -2. But here in this case, see, u is what? U is equal to x to the power 8 f of y by x. This is the first term. And second term is what? 1 by y to the power 8 f of x by y. Here the degree of this term is 8 and degree of this term is -8. You cannot apply directly Euler's theorem on u. So what to do? येताना मला दिसलं नाही, मला धक्का लागला बघून दिसलो ना. Yes. Now next sum. If u is equal to x to the power 8 function of y by x, y to the power -8 function of x by y, then find the value of x square del 2u by del x square plus 2xy del 2u by del y del x del y plus y square del 2u by del y square plus x del u by del x plus y del u by del. Okay, the value of this we have to find. Now here in last problem, in this problem there were 3 terms, and especially the degree of first term was -2, degree of second term was -2, and degree of third term was -2. Therefore I didn't let here this is equal to u, this is equal to v, this is equal to w. But you can do like that also, but it will take more time. But degree of n for this term, n for this term, n for this term, n for all the terms are same, which is -2. Okay. Therefore, directly Euler's theorem I have applied on f. Okay. In this sum, see, here there are two terms, first term and second term. But degree of this is standard homogeneous function. Standard homogeneous function. First term and second term. Here degree of this term is 8 and degree of this term is -8. You cannot apply directly on u. So we have to let here, I am going to let v is equal to first function. Okay. And w is equal to second. Okay. See, this in examination 8 may be replaced by any other integer. 8 may be replaced by n also. 8 may be replaced by 3 also, 2 also, 4 also, like that. Now, in short, we are going to solve this problem. See, here by Euler's theorem, first order differential coefficient x del v by del x plus y del v by del y is equal to nb. Okay, here 8b I am writing, n is 8 directly. Now sufficient practice is done on Euler's theorem. I am writing directly now. By Euler's theorem, for w del w by del x plus w x del w by del x plus y del w by del y is equal to -8. N is -8w. Okay. Now I am going to add both of them. This implies, see, this term I am going to add x del x of v plus w is u, because this is v, this is w. Therefore, u is what? U is v plus w. Okay. Plus, add these two terms y del y, and v plus w is u. The right hand side is 8v minus 8w. Okay. Means this much component I found, x del u by del x plus y del u by del y. Now for v and w, the second order differential coefficient I am writing by Euler's theorem. Okay, by Euler's theorem, x square del 2v by del x square plus 2xy del 2v by del x del y plus y square del 2v by del y square is equal to n minus 1. N is 8 here, for v. N minus 1 into v. This is what? 8 multiplied by 7 is 56v. Okay. For w I am writing x square del 2w by del x square plus 2xy del 2w by del x del y plus y square del 2w by del y square is equal to, here for w n is minus 8, n is minus n minus 1 w. This is equal to this minus 8 and minus 9. this is 72 minus 8 multiplied by minus 9, 72W. Okay. Now I am going to add equation 1 and equation 2. Okay. This 1 plus 2, equation 1 plus equation 2 gives, okay, see I am adding first term x square del 2 by del x square, v plus w is u, 2xy is common, del 2 del x del y, you can say it is a common component, v plus w is u, y square del 2 del y square, here v plus w is u, left hand side I have added, the right hand side of equation 1 and equation 2 I am going to add 56v plus 72w. Okay, this is our equation 3, right? See, we have found value of this also. Initially value of this component I found, and then value of this component by Euler's theorem we have found. Now adding, we want addition of these two. Add equation 3 and you may call this as equation 0. I am going to add equation 0 and equation 3. Equation 0 and equation 3 I am going to add. What will you get? X square del 2u by del x square plus 2xy del 2u by del x del y, as it is. Complete thing is as it is. Y square del 2u by del y square. This component of equation 3 and this side of equation 0 is what? X del u by del x plus y del u by del y. Left hand side I have added. Left hand side I have added. Similarly, right hand side you have to add. Right hand side of equation 0 is 8v minus 8w plus 56v plus 72w. Is it? Now add them. Left hand side is same. 72, 56 plus 8 is 64v. And 72 minus 8 is again 64. 64w. And 64 is common. 64 is common and v plus w is u. In this way, we solve this problem. The value of this whole thing is 64u. And what is u? U is x to the power 8 f of y by x. U is x to the power 8 f of y by x. You can put the value of u here. If you don't put it, it is also okay. Right? Now we stop here for Euler's theorem. We have done sufficient practice on Euler's theorem. In Euler's theorem, there are two sets of formulae. First one is the extension. First one is what? For z, and second set of formula for z equal to f of u. In second set or in extension of Euler's theorem, the z is a function of u is there, and in those problems single term is given, is cosec inverse, cos inverse, tan inverse, sin inverse, like that. Okay, and even log also. So you have to shift those functions on the left hand side, that will be f of u means z, and you have to operate it like that. Okay, thank you very much.